Our geochemistry operation was maturing, so we got to look around and said, what do we do next? Let's go into space science, because the bus, in a sense, is right at our back door. Through JPL, we have an opportunity to participate. We had a greater chance for uniqueness by aligning with the space program.
Bob Sharp's vision was to, in fact, create a new science area, that is planetary science.
Caltech invented the field of planetary sciences.
Planetary science is the study of all planets. It includes Earth. It includes planets outside the solar system. It could even include planets in interstellar space. And it is all aspects of those planets. The first planetary science professor at Caltech was Bruce Murray. Bruce was involved in the earliest work to understand what happens to water on other bodies. Could you find water ice on the surface of the moon? Would there be ice caps on Mars? New questions at the time in the 1960s, and pushed us forward in our understanding.
We had a number of wonderful geologists, including Bob Sharp, Jerry Wasserberg, Lee Silver, Sam Epstein, who played very important roles in training the astronauts and analyzing the lunar rocks and telling us about the history of the moon.
Another great pioneer is Gene Shoemaker. His most important scientific accomplishment was to understand bodies that hit the Earth, such as Meteor Crater in Arizona and bigger events in the past. This is an essential part of understanding planets.
For the first 18 years of my relationship with JPL, I was part of the Voyager team as the chief scientist, and I still have that role today. Voyager flew by the giant outer planets, Jupiter, Saturn, Uranus, and Neptune, and really revealed the diversity of objects in the solar system. It greatly broadened our otherwise Terra-centric view. What's wonderful about Voyager is that after 36 years, it's still on a frontier. It's still in a mission of discovery, exploring this new realm, the space between the stars.
I think one of the amazing things about Caltech planetary science is that it is so diverse, but that there is excellence across all of that diversity. And I think that's what has sustained this planetary science department through time, but has also made it the best in the world.
People who do planetary science are the people who fly spacecraft around the solar system, get to drive around on Mars, get to fly by Titan and take pictures. It's an exciting thing that you get to do because you're studying these other bodies in the same way that you would otherwise be studying the Earth. But there's another very important part. One of the particularly nice things about being at Caltech is rich in telescopes. Most of the best telescopes in the world are in some way associated with Caltech. So a lot of the time I spend looking at things at the very outer edge of our solar system. These things past Neptune, these things like Pluto is one of the other large objects out there that were for the most part discovered here at Caltech by my group. And each one of these objects was like a little world, and each little world contained a little bit of the history of the solar system as a puzzle in it that you had to figure out. Pluto was really part of this class of all these objects that were being discovered. It was obvious to astronomers that really Pluto deserved to be classified with these things and not with the other 8 actual, real remaining planets.
So as a geologist by training, I enjoy the fact that an atmospheric dynamicist, a physicist, an atmospheric chemist, and an astronomer are down the hall because it encourages creativity and a thinking in new directions that I think is really unique.
My research is focused on understanding the properties of planets orbiting stars other than the sun, so we call these planets extrasolar planets. But my job is really to put a face on the planet, to kind of fill in this very sketchy picture that we began with. So I try to answer questions like, does the planet have an atmosphere? What's the atmosphere made of? Can we tell what the temperature of the planet is? And in particular, if it's an Earth-like planet, is it at the right temperature to perhaps have liquid water?
My research focuses mostly on the composition of planets through remote sensing, looking with satellites, looking with rovers. I'm especially intrigued by the history of Mars. It's the planet in our solar system, in some ways with a history that's closest to our own on Earth, but we really don't quite understand how Mars worked. It was once a lot like Earth. Now it is cold, dry, and desolate. So what happened? And I think that by studying this, we learn a lot about how planets work. We learn about how our own planet works.
One of the really neat things about Caltech is its close proximity to JPL. JPL was a laboratory that emerged from Caltech. In the last 50 years, the prominent role that JPL has played in mission science enables Caltech to all get involved in a very intimate way with mission science, and it's that close proximity that allows you to really rub elbows with the people that are doing rocket science, and it's just a lot of fun.
You can bring these two groups of people together to do new things, to have the scientists develop new ideas of things that we should be doing in planetary science, and get them together with engineers who know how to make it happen.
MSL, which stands for Mars Science Laboratory, is really about the Curiosity rover. And we take this rover and drive it around the surface of Mars and ask a very basic question: is there life on Mars?
I went to the launch of MSL, and I was really struck by the sheer audacity of what we were doing. To watch a rocket get launched, has a little payload on the top, and have it land in an area that was 10 kilometers across. It amazed me. It was awe-inspiring that we have reached the point where we can do it and do it successfully. And then, that's not enough. We have to actually do science.
Curiosity is breaking ground and establishing what the nature of the physical and chemical environment was and whether or not microorganisms could have lived there. And it's great for us because we've been able to make a discovery that suggests that that is in fact the case. Curiosity, it's really an extension of ourselves. It allows us as human beings to explore another planet. It extends us, it challenges us, it asks us to go in different directions. And it really makes you understand what your place is in the universe. And I think the Curiosity mission does that to a lot of people.
One of the things that I've really enjoyed has actually been the opportunity to teach students. This is often their first encounter with kind of cutting-edge research, and it's great to be able to share that process of exploration with them.
It has, for me, been a tremendous personal pleasure and satisfaction to work with these wonderful young people coming from all over the world. It is always invigorating to see people with so much enthusiasm and then to see how successful they are, for indeed they are often to be found as the professors of planetary science at other institutions or the leaders at NASA centers such as JPL.
One of the things I get to do as division chair is I get to interact with the public and with donors in a way that I wouldn't as a professor.
Even though I did not attend Caltech, I'm not an alum, and yet I feel very much a part of the Caltech family. I feel like I have become part of a community of people that are discovering amazing new things about our world, about our universe.
And it makes me feel like what we're doing is not just an egghead discipline, that there are people out there who are watching what we're doing, who are really interested in it, and they understand that part of it is about science, part of it is about getting it out to the public, using it as a tool to make sure that we as a country are educating people in math and science and engineering, getting them excited about that as young people so that they can keep us moving forward in the coming decades.
I love learning about the planets and the universe, and I think there are many that share that same sense of wonder and awe. I mean, who hasn't gone out and looked up at the night sky and wondered what's out there?
Planetary science addresses questions that people have been posing since biblical times, like where do we come from, where are we going?
What is it that makes a planet habitable through time? How does water end up on some planets and not others?
What is the largest object out there beyond where the Kuiper Belt is?
Is our solar system representative of the universe? Is there life on Mars?
Are we actually alone in the universe, or is the universe just this place which is teeming with life? Is it really everywhere?
How did the solar system form? How did it take its present distribution of planets?
We have all these very exciting questions that we really desperately want to know the answer to, except that the most exciting part of all of it is not getting to know the answer. It's the journey, it's finding the answers, it's the exploration, and that's the part that makes it exciting to do the science of planetary science.
And I expect that if Bob Sharp were alive right now, he would be saying, "What's next? What's next?"